Question 1.8. You've got a reaction with A, B and C as reactants, and it's making D and E is blue. It's a dark blue colour. So the reactants will go blue straight away as E is made. However, you can add a reagent X, and what X does, it reacts with E. And so as it reacts with E, then there won't be any blue colour. But when X runs out, then E is produced and the blue colour appears. So whilst X is still not fully used up, then E won't be produced and it won't be blue. It's only when X runs out that E will appear. So what we're going to do is we're going to try and determine the order of reaction with respect to A. So we're going to have to change the concentration of A and see how that affects the reaction. The amounts of B and C, the volumes of B and C and the concentrations of B and C will stay the same. And we're going to use a fixed amount of X to keep the reaction fair, to keep the experiment fair. So first of all, we're going to have to measure out a set volume of A, a set volume of B and a set volume of C in separate containers. Yeah. We'll measure out a volume of X into a separate container as well. So I've got a certain amount of A, a certain amount of B, a certain amount of C and a certain amount of X in separate containers, in separate beakers, let's say. It doesn't matter how much you have. Next, we're going to put X into the reaction mixture. It says that you put X in first. A small amount of X is included in the initial reaction mixture, so X will go in first, and then maybe you'll add A and B and start the reaction by adding the third chemical C. So you add X, which is the reagent which is going to react with E, and A and B, and you can start the reaction by adding the third chemical C, and you're going to start a timer, a stopwatch, and then you time how long it takes for X to be used up, or rather for the E to start appearing and the blue colour appears. Then you repeat it with different volumes of A, and from that experiment then we can work out the initial rate of the reaction. So what's going to be fair each time? We've said already the total volume. So the total amounts, even though we're varying A, will make up the remainder with water, so that the concentration of A changes, but the amounts of B and C are the same. So we'll keep the amount of B and C the same, and the concentrations of B and C the same by using the same amounts each time. And we'll vary the amount of A, but we'll change the concentration of A by making it up to the same volume each time. We'll have to use the same temperature as well, so temperature doesn't affect the reaction. And then what we're going to do is we're going to plot a value of 1 against time against the concentrations of A. That's fairly standard for working out for a plot of from a rate equation. Order from the shape of the graph will tell you what kind of order with respect to A that's going to be. If it's a straight line, it'll be first order. If it's a curve, it'll be second order.